Okay. So we're going to switch gears quite a bit here and start talking a little bit about the properties of parallelogram. But again, this is going to go very easily for you. Most of these are the same exact thing as a rectangle. It's just you don't have the 90-degree angles. So let's talk about the definition of a parallelogram. What makes something a parallelogram? What word is pointing out to you in the word parallelogram? Parallel, right? And that's what the definition is. It's a quadrilateral. So what does that mean? Four sides, a four-sided figure where both pairs of opposite sides are parallel. That's what makes it a parallelogram. Okay, so rectangles are in the family of parallelograms. Squares are in the family of parallelograms. A trapezoid, not a parallelogram. Okay, so if, and I have this little picture kind of at the bottom here for you, if ABCD is a parallelogram, then AB is parallel to CD, and AD is parallel to BC. So you can put little parallel markings there. We're going to add some other markings to it, so if you want to hold off for a minute, we'll actually take a few notes on the bottom of that. Now, along with the opposite sides being parallel, the opposite sides are also congruent to each other. So they're always going to be the same length. So if a quadrilateral is a parallelogram, then its opposite sides are also congruent to each other, not just parallel. And then if it's a parallelogram, then its opposite angles are also congruent. It sounds like a lot of information, but really most of it is kind of common sense. Oh, come back. Okay, so if these are my notes, I would just jot a few things down at the bottom here. I would probably, you guys have a picture looks like this. I'd probably put little parallel markings on mine. And write that AB is parallel to CD and AD is parallel to BC. Okay, there's the definition of a parallelogram. The opposite sides are parallel. The opposite sides are also congruent. So AB is congruent to CD. What does congruent mean? Same length, very good. And AD is congruent to BC. So they're parallel and the same length. And then the opposite angles are congruent. Who can raise their hand and give me an example of opposite angles in this picture? Savannah? Very good. A and C. And I'm allowed to just call them A and C because there's only one angle there. So A and C. And then, what else? B and D. Okay. So that first example problem is going to be what a lot of the homework is for the next couple of sections. And section 2 is just like, or section 3, excuse me, is just the converse of section 2. So it's really like the exact same lesson. Okay, so if they're asking me to find the values of x and y, it's probably exactly what you think it is. This is a pair of opposite sides, which means they're congruent to each other. So what can I do with these two expressions? Set them equal. Yep, don't want to add them together because you'd have nothing to solve for. Or set them equal. It doesn't say plug in. If you did plug in, you should get 12. And then same thing for y. That's a pair of opposite angles there. And you're going to be asked to start defending like why you're doing that, and you would just write like opposite angles are congruent, and that's why y just has to straight up equal 65 degrees. Okay, and there's just two more little properties of the parallelogram, and then we'll probably call it good for today. The fourth property has to deal with consecutive angles. Does anybody remember what the word consecutive sort of means? Next to, absolutely, very good. So in a parallelogram, it's consecutive angles are not equal to each other, but just like in chapter 3, they're going to be supplementary. Now, we actually dealt with parallelograms in chapter 3. We looked at them. When you think about these consecutive interior angles, here's a pair of parallel lines, here's a transversal, so the angles that are on the same side of the transversal between the two parallel lines are consecutive interior angles and are therefore adding up to 180. So I'm just going to throw a couple of examples up here. Angle A and angle D are going to add up to 180. A and B add up to 180. Technically also I should have little M's in front. Sorry, guys. B and C add up to 180, so on and so forth. So any two angles essentially that aren't opposites of each other are going to add up to 180. And then the last theorem is in a parallelogram, its diagonals bisect each other. Now we have to be very careful with this one. I did not say the diagonals were congruent. I said the diagonals bisect each other. What does bisect mean? Cut in half. They're cutting each other in half. So that means that this diagonal AC is being cut in half by BD, and BD is being cut in half by AC. The red and the green are not equal to each other. They are not the same. The green segment is shorter than the red segment. When you have a slanted figure like that, one diagonal will always be longer than the other diagonal because it's a slanted figure. But what it means is that the two halves of AC, so AM and MC, are going to be congruent to each other. And the two halves of the other diagonal are going to be congruent to each other. But AC does not equal BD. No, that's a special shape. But a normal parallelogram, the diagonals are not the same length, and that should make sense. One of them has to be longer because the corners are further apart because it's slanted. But they're cutting each other in half. So we're probably not going to get to the examples because I want you to have a little bit of time to work here. But it's, again, setting a lot of things equal to each other except for the consecutive interior angles. The consecutive interior are going to add up an equal 180. So, I mean, for 7.2, that covered everything up to number 18. We'll see how far you get here. I don't know. I know that was a lot of information, and I hate doing two sections in one day. But your homework is essentially going to be to finish up the 7.1. That's your first priority. And if you're done with 7.1 and you're ready to turn it in, you guys can go ahead and do so. But if it's not done, you got to finish that up tonight. And then let's start the 7.2 and see how far you get on 7.2. 7.2 is pretty easy, so I think you'll find it pretty straightforward and quick.